Morning, everybody. Let me double check that my microphone is working. It is. Good morning. Thanks for coming to the live stream. I appreciate not talking to nobody. Although watching this later is perfectly fine too. Okay, so we are learning about volume today. Probably not for the first time. I'm sure you've seen volume plenty before. But today we're going to try to break it down into sort of the basics of what volume means so that you don't have to memorize a bunch of formulas, because I hate doing that and I don't feel like it's useful. So what we're going to do, I have sort of categorized all three-dimensional shapes into a couple of categories, so that and then we're going to talk about how to find the volume of each of these categories. There's only 3. And one of the categories is just sphere, because spheres don't fit in with anybody else. we just made him his own category. So first is prisms. So a prism is any three-dimensional shape where it has a base of a shape. So this example that you're seeing on your page is a triangular prism, because the base is a triangle. So it has a base of a certain shape, and then all the other shapes are rectangles. All the other sides are rectangles, surfaces. That's what I'm trying to say. So prisms are essentially just, you take a shape and you stretch that shape into 3 dimensions, so that it has all of its sides as rectangles, and then the top and the bottom are the same shape. They're just whatever the base is. So rectangular prisms are a thing. Triangular prisms are a thing. Circular prisms are actually called cylinders, and we'll see that in a second. But yeah. Anyhow, so there's a bunch of different kinds of prisms, but anytime you encounter a prism and you're trying to find the volume of it, the formula is that you just find the area of whatever its base is and then multiply it by its height. So I'm going to sort of annotate on here. I'm going to change colors. There you go. The base in this image is this triangle, although not all of the shapes you'll encounter are triangles, of course, triangular prisms. So you're finding the area of that shape, and then you multiply it by whatever the height is, which is however long it's stretched the other direction. So you find the area and you multiply it by its height. That's all you do. So we're looking at this formula, which it's not really a formula. It's just the area of the base times the height. So we'll do a couple examples down here. The first one is a triangular prism, because that was the example. So we're going to look at the base. The first step of these is to sort of identify the base. Rectangular prisms are a little bit different, but we'll talk about that in a second. So the base on this one is this triangle. That's all the other faces of this shape are rectangles. So so that's the base. And then you have to pull from your memory how to find the area of a triangle, which is, so first I'm just going to write what I'm doing here. The volume of this shape is equal to whatever that triangle is, the area of that triangle. Let me try again there. Area of the triangle times the height. That's all I'm doing. So my triangle is going to be base times height divided by 2. And I'll just write that formula. Base times height over 2 is the area of a triangle. And pardon my variables here, because they're not actually going to be the same. So this height out here is a different height because it's the depth of the shape. I don't want to confuse you. All I'm doing is finding the area of the triangle, which is base times height divided by 2, the base of the triangle and the height of the triangle. So in this case, it's 4 times 3 divided by 2. And then the height of this shape is that 11. That's how like deep or how tall you've stretched this prism. So our height, the other height, which is this piece, is 11. And then you can type that into a calculator or you can do it in your head if you want to, but I believe it's 66 centimeters. And remember that volume has cubed on the units because we're trying to figure out how many of those like 1 centimeter cubes fit into this shape. If we were in class, Mrs. Olson gave me these really cool like containers basically that are the shapes of these like prisms and pyramids and stuff that you can fill with water, and you can do sort of experiments with them, and it would have been really cool, but I don't have them here, so it's gonna be more boring. But just know that it could have been very cool. Anyway, so the volume of this one is 66 centimeters cubed because there's 66 centimeter little 1 centimeter cubes that fit into this shape. So the next one is a rectangular prism, and at first glance you might say, okay, but what's the base? Because all of the sides are rectangles, so does it matter? And my answer to you is no, it does not matter which face you pick on these rectangular prisms because any of the faces could be its base. It's going to give you the same volume whichever one you pick. So you are allowed to pick any of the sides as your base. I'm just going to pick the front one. I'm going to pick this side as my base. So the volume of this is going to be this rectangle times the height, which is like 2.7 in this one. I'll do that in a different color. Nope, I'm just do height on that one. That's going to be my height. Okay, so the area of the base is a rectangle, so it's just base times height. So we have 4.2 times the height of this rectangle is the same as this. So it's 4.2 times 6.3 times 2.7 and calculator. Double checking my work because I don't want to do it wrong. 4.2 times 6.3 times 2.7 is 71.442. I'm just going to do 0.4 centimeters cubed. So 71.441442 centimeter cubes fit into that rectangular prism. The last one is actually a cylinder. People do not call this a circular prism, but I think they should because it is a prism. It's just the base is just a circle. So whatever. Anyway, the formula is still the same for this. For cylinders, you just find the area of the base, which is a circle in this case, and then you multiply it by the height. Circular prism. I mean, that's fine, right? Cylinder, whatever. So the area of my base volume is going to be the circle times the height, which is 20.1 inches in this case. A circle, the area of a circle is pi times the radius squared. I'm actually going to write that formula down just so we know what we're doing later. So pi times the radius is 6.4 squared times 20.1. So if I were you, I would just type that into a calculator because I don't want to do calculations with pi. Double check me on my answer on this one, but I think it's 2000. That feels wrong. I'll double check it after I write it. 2,586.5 inches cubed. Okay, pi times 6.4 squared times 20.1. Yeah, that's right. 2,586.4. Good. So those are prisms. Clearly there's plenty different kinds of prisms that you could have. I mean, technically you could have like a hexagonal prism where the base is a hexagon or literally anything. But no matter what prism it is, that is the formula for finding the volume of a prism. You just find the area of the base and then you multiply it by its height. And the only other weird thing is that the rectangular prisms don't have a specific base because anything could be its base, so you just pick one and go for it. We are next going to talk about pyramids, and the way that I'm defining a pyramid is just that it has a base of some shape and then it comes to a point. And all of those other sides are triangles. So pyramids could be a lot of different things. This example here is a rectangular pyramid, because notice that the base is a rectangle. The way that it's, because of perspective, it looks like a parallelogram, but it's not. It's a rectangular pyramid. You could also have a triangular pyramid. You could have a circular pyramid, which we call a cone, another thing that I disagree with. And then literally you could turn anything into a pyramid. It just has a base of some shape and it all comes to a point, the opposite that shape. So the volume of a pyramid can always be found by finding the area of the base and then multiplying it by 1/3 times its height. So the only thing that we added here is that this is going to be 1/3. This is what we added here. This 1/3. The reason for that is because if we were just multiplying by its height, it would be for the full prism shape above that base. But that 1/3, that 1/3 is built in there is finding the area of just if it came to a point, which is what we're looking for. So clearly coming to a point is going to give you less of a volume than a whole prism. And in fact, it's exactly 1/3 of what it would be if it was a prism. So that's just the overall rule, and it works for any kind of pyramid, any base. And the height, you just have to remember that the height is its vertical height. So it can't be the slant height. It can't be how long those like slanted sides are. It has to be actually how tall is this. So I drew that with blue, but you can hardly see it. Maybe I'll draw it with a different blue. There we go. That's our height. So we now have a rectangular pyramid for number 1. So our goal here is just to find, let's write out what we're doing. The volume is going to be the area of this rectangle, because that's the base, times 1/3 times its height. Perfect. Rectangles area are just base times height. So in this rectangle, the base and the height are 13 and 6. So we're just multiplying those two things together. That will give us the area. 13 times 6 gives us the area of that rectangle on the bottom. And then we have 1/3. And then times the height of this rectangular pyramid is 14. And we can just type that all into a calculator. I'm sorry that my 13 looks like a B. I smushed my numbers together. And if my work from before is correct, I got 364 centimeters cubed. Double check me on that. So just the area of the base times 1/3 times its height. Okay. For number 2, it's a triangular pyramid because its base is a triangle. You might also notice that all of the sides of this shape are triangles. And this kind of like the one on the last page where we had a rectangular prism, because all of its sides are the same, you can actually pick any side you want to be the base. However, on the specific shape, it only gives us the measurements for this base, so we're just going to use this one. Yeah, because that's what we have the information for. So what we're doing here is we're going to find the volume by finding the area of the base, which is a triangle, times the height, which is 20. So the area of a triangle, again, is base times height divided by 2. So our triangle has a 17 base and a height of 10, and we divide that by 2, times the height is 20. Yeah, I'm going to type that into a calculator to figure out what that will be. 17 times 10 divided by 2 times, oh, you know what I forgot? The 1/3. That was my bad. I'm finding the prism instead. Let me fix that. So we have 1/3, 1/3. That's the easiest part to forget. That's better. Okay, I got 566.7 if we're rounding. Inches cubed. Cool. Number 3 is a cone, also known as, in my world, a circular pyramid, because the base is a circle and it comes to a point opposite that. So, and the rules are the same for this one. You find the area of the base, times 1/3, I'm not going to forget that this time, times the height. And the height of this one looks like 7. This is a tricky one because it gives us this information that we don't need. We do not need the slant height of this. We never need the slant height, like, ever. Unless we need to use it to get something else that we do need, but usually not. So we do not need that 7.6. Because we're just trying to find the volume or the area of the base. And the area of the base is pi times the radius squared. And the radius is 3. Then you have times the 1/3 times the height of 7. And all of that comes to 65.97 centimeters cubed. Do let me know if you have any questions. I know that I'm going fast, but that's because you can pause me. So just let me know. Yeah, so we've got prisms, which just come, they're just basically a base stretched taller so that all of these faces around it are rectangles, and then the base and the two bases are the same shape. A pyramid, base of some shape, and it comes to a point. So circular pyramid, circular pyramid, or triangular pyramid, or rectangular pyramid, or pentagonal pyramid. It could be anything. Last category we have is the loner that doesn't fit into any other categories, and that is a sphere. Because it's not a pyramid or a prism, it's just a circle any way you look at it. So doesn't fit in, but it's okay. This is something just to sort of start thinking about your note card early. This is the last lesson of this unit, so sorry, I'm reading messages. This is the last lesson of this unit, so next week we'll be working on our performance task and our test. No, will we have our test? No, because Friday I think is the service day. So anyway, next week we'll work on preparing for your test. So just think about your note card. There are a lot of formulas this unit, not just because it's a bunch of area and geometry and volume. So just start thinking about what things you would like to put on your note card. These giant things in boxes are usually indicating that they're important, especially the sphere one because it doesn't fit into any other category. And so it's kind of one of those ones where it's like kind of you have to memorize it. Anyway, because I can't really, I can't really explain why it is that way without it making more complicated than it needs to be. So the volume of a sphere formula is just 4/3 pi r cubed. The thing that I mostly see when people mess up this formula is they put 3/4 instead of 4/3. Just make sure you get that right. 4/3 is an improper fraction. It's more than 1. 4 divided by 3. Just make sure that that's correct on your note card. And we are actually going to, instead of practicing with spheres, because it's boring, we'll practice with spheres kind of later. But we're going to look at some compound volume, because that is sort of the extra layer we're adding today to what you already have in your past math career. Compound volume is very much the same as compound area. You're just putting a bunch of different shapes together and you're trying to just adding all of their volumes together. For example, this first one is like, it looks to me like a rectangular prism on the bottom where it has all rectangle sides. So that whole bottom could be a rectangular prism. And then the top piece looks like a prism, but the base is a trapezoid. That's what it looks like to me. And that's fine. We know how to find the area of a trapezoid. So we could find the area or the volume of a trapezoidal prism. I don't know if I made that word up. So I'm going to do that. I'm going to find the area of this trapezoid. As a part of this. Let's maybe do a little step in here in between. If you're bad at drawing three-dimensional shapes, I'm sorry, sometimes so am I. So we have two pieces here. We have a trapezoidal prism. I'm going to go with that word. Makes me sound cool. And then we have a rectangular prism on the bottom. Yeah. There we go. Okay, so for the trapezoidal prism, we have a base of a trapezoid, which I do not blame you if you need to go look at that formula, but a trapezoid is base 1 plus base 2 divided by 2 times the height. So I'm going to write that here. Divided by 2 times the height. Your formula might look different on your page, but that's okay. And then remember that this is a prism, and that's just the area of the base. And we need to add the area or the height of the prism. which in this case is going to be 9 because it's that thickness of this shape. So this is like the area of the, maybe I can fit it inside of a trapezoid. I don't know if I'm cool enough. There you go. Made it work. There's the trapezoid, and then we need the times the height of that piece, and then we're adding a rectangular prism, which I'm going to say the face is this, or the base is this first, this like front rectangle. Remember, rectangular prisms don't really have a specific base. It could be any of them. So anyway, but that is just going to be base times height because it's a rectangle times the height of that prism. So now we just have a bunch of formulas we need to figure out what each thing is. So on the trapezoid, base 1 and base 2 are the top and the bottom pieces of the trapezoid. And it doesn't actually directly label any of the ones that I have right here, but remember that on these kinds of shapes, these measurements are often the same. Like this is still going to be 30 because that's a rectangle, and this is still going to be 19 because that's top piece is a rectangle. So our base 1 and base 2 are 19 and 30. So we have 19 plus 30 divided by 2 times the height of the trapezoid is 10. So we have times 10, and that's just all for the area of the trapezoid. And then we multiply by the depth of this, which ended up being 9, because all of these are 9, times 9. And then we can add, and you can do these separately and add them together. I don't know what way works better for your brain. I like to do it this way, but it doesn't matter to me which way you do it. Just as long as you're eventually adding the volume of the bottom to the volume of the top, it doesn't matter. You'll get the same answer if you do it right. So rectangular prism, we're just doing the area of the rectangle, the front rectangle, and the base and the height of that front rectangle are 7 and 30. So it'll be 7 times 30 times the height is 9. And now it's time to type all of that into a calculator. For once in your life, you have room. I was thinking ahead on this lesson. Good for me. 19 plus 30 divided by 2. No, that's not going to work. 19. I just didn't put enough parentheses, so be careful that you're putting enough parentheses. 2 times 10 times 9 plus 7 times 30 times 9. Okay, I'm just trying to figure out why my paper is wrong. I figured it out. Okay, I got 40,095 yards cubed. Double check me on that if I'm wrong. Let me know. That's what I got. And again, if it helps you keep it straight, you can just do the trapezoidal prism and then the rectangular prism, and then at the end add those together. I don't know which way. I mean, sometimes I do it one way and sometimes I do it the other. So great, compound shapes. Okay, so this shape is clearly, we have a circular prism slash cylinder on the bottom, and then a circular pyramid slash cone on the top. So we have, oh, it's snowing. I thought that was a lie. Oh well. Anyway, sorry, I'm distracted today. Okay, so we have, our volume is going to be the sum. We have a cylinder and a cone. And for the cylinder, it's going to be the area of the base times, because that's like a prism, so it's the area of the base times the height. To answer your question, Philip, about why we're multiplying by 9 on those ones, so you have to think about it in terms of where the base is. Like, I know it's confusing because I'm using like the depth as a height, if you know what I mean, but I picked the front as my base, so like the height of it is going to be how deep it is. So basically, if you've already used one of those numbers, you shouldn't be using it again as the height. Like, I already used that as for the area of the base of the rectangle, the rectangular base. I already used 7. So 9 was the only one that I didn't use. That's like the depth. That's what I needed. So on both of those, I picked the front part as my base. So the height was the other dimension, the depth, I guess. Hopefully that helps. And then for the cone, this is one that comes to a point. So the ones that come to a point have a 1/3 in there. That's the piece that's different. So for the cone it's going to be the circle times 1/3 times the height. Yeah. So the convenient thing. Well, okay. First, let's just talk about the cylinder. So for the cylinder, the base is this piece. And it says that the radius is 4 millimeters. So we have pi times 4 squared, because the circle is pi r squared, times the height of that cylinder is 3 millimeters. And then we move to the cone. The cone's base is actually the exact same as the cylinder's base, because that's a cylinder, so the two top and the bottom are the same circle. So we can actually use, it's going to be pi times 4 squared again for that cone's base. And then we have times 1/3, and the height of the cone is 5.5 millimeters. And now it's a bunch of calculator stuff. I'm going to type these two pieces in separately and then add them together. Uh-oh, my calculator's running out of batteries. Don't die on me now. Pi times 4 squared times 3. So the first one is 150.796. I was trying to decide where to round that, but I'm just going to go like 3 decimal places. And then we have pi times 4 squared times 1/3 times 5.5. And if it helps anybody, the way that you type in 1/3 in a calculator is 1 divided by 3. Or you could just divide by 3 at the end. Either of those things work. 92.153. And then you add those two things together. And that equals 242.95 millimeters cubed. Let me check mine. 242.95, yeah. Yep. Okay. Hopefully this doesn't feel too crazy. I didn't want it to feel super crazy. I know it's kind of, it's new, but it's just putting together what you know before. So yeah, so hopefully it's not too bad. Alrighty. For this shape, it is a cylinder, and the top part is half of a sphere. So the way that we're going to need to find this volume is going to be a cylinder plus 1/2 of a sphere. There you go. A cylinder plus half of a sphere. For the cylinder, the volume is going to be the base, which is a circle, times the height, because it is just a prism, plus, and then this part is the sphere. So the 1/2 I'm just leaving out front because the 1/2 is not actually part of the formula. The 1/2 is because it's only half of a sphere. So half of a sphere is going to be half of 4/3 pi r cubed. That part that I just put in there is the formula for a sphere. Double check the other side of your page if you need to. And now we just need numbers. So the circle is a pi r squared. The way that I keep those straight, by the way, is that pi r squared is the area, and area is always like squared. It's like the number of squares that fit in there, and cubed is the number of cubes that fit in there. So like pi r cubed is for the volume formula, pi r squared is for the area. It has the 4/3 on there, but anyway, that's why you just kind of have to memorize that one. Okay, circle area formula is pi times the radius, which is 2.3 millimeters squared, times the height of that prism is 5.6. Yep. Plus 1/2 times 4/3 pi times the radius of the sphere. So here's the thought. The sphere is exactly covering the cylinder. So this shape is exactly the same as this shape, meaning that this radius right here is going to be the same as this radius down here. And the radius of that piece of a sphere is going to be the radius of the whole sphere as well. Like any radius works. So the radius is actually the exact same as the cylinder's radius. Nope, not squared, cubed. I'm just using those brackets to make sure I know where the actual formula is, and the 1/2 is like an addition we made because it's half of a sphere. And now we can put it into a calculator. I'm gonna put the whole thing into the calculator because these have pi in it. Pi makes it hard to round and still not lose some decimal places. So I don't know. I recommend typing this whole thing in. 1/2 times 4/3 times pi times 2.3 cubed. Yes. 118.55 meters cubed. There we go. Okay, one last one. Look at that. It's not even 40 yet. 10:40. Doing good on time today. This one is it has pretty clear partitions here. I don't know why every single one has a cylinder. Oh wait, the first one did it. Anyway, so we have another cylinder on the top, and then the bottom piece. Notice that it's not perspective that's making that look like a parallelogram. It really is a parallelogram, and it's a parallelogram prism. I don't think there's a word for that, but it's a prism with a parallelogram base. So we're going to need to use the parallelogram formula, which isn't any different than the rectangular um, rectangle formula. Hint, hint. And then this is what we're going to use for the height on that one, and this is the height on this one. So basically it's two prisms, one that's got a circular base and one that's got a parallelogram base. So our volume is going to be this cylinder on the top plus a parallelogram prism. Yikes, that's not very good, but you get what I mean. And then because each of those are prisms, we're just finding the area of the base times the height. Area of the base, which is a parallelogram, times the height. Notice again that I'm using different directions as the height. The height is not really always how tall it is. It's because it depends on where you pick your base. So on the bottom shape, I'm picking the front as the base because that's the one that's a parallelogram. The other sides are rectangles. So I'm picking the front as the base, so the height is going to be how the other dimension. And the top one, I'm actually using the bottom as the base and the top. So the height is actually how tall it is. It's the other dimension. So, yeah, I know that can get confusing. So let's do the cylinder first. So notice the weird thing about this one is that it doesn't have a radius. The only information we have is that circle, the diameter, the whole circle touches the both edges of the parallelogram, meaning that this whole thing is 14 yards. So as you might imagine, that means that the radius is going to be half of that, which is 7 yards. So we kind of had to do a little bit of connective reasoning there, but that's okay. And that makes the formula pi times 7 squared times the height of that shape, which is the cylinder, is 17. That's the last dimension that I haven't used yet. And then parallelograms, remember parallelograms are just base times height because you can like move this little triangle over to this other side and it becomes a rectangle. So yeah, anyway, I'm drawing all over my piece and I don't want it to be too confusing. But yeah, same formula. So it's just base times height. So the base of this one is 14 times the height is 8 times the height of the shape, which is the other dimension, or kind of like the depth in this direction, but the last piece. So yeah, that gives us 14 times 8 times 11. And now we can type that all in. Because I have pi in there again, I do not want to find it separately because that means I'll have to round, and I don't want to round until the end. Oops. Times 17 plus 14 times 8 times 11. Pi r squared times 17. Yeah, okay. So I'm pretty sure that 3848.95, the units, yards, cubed. Okay, and that is that. Do you guys have any questions? Can I answer any questions for you? Just as a reminder, I am going to have a study session today, probably at 11 because I have to be at a meeting later, so I'm going to do it pretty soon here. Having a study session, so please join if you need help. 9-2, the area one, is due today at 5. Please don't forget that one. And then you can also work on this one, which is the volume one. This one isn't due until Monday, but maybe work on it now before you forget everything you learned. Yeah. Okay, well, if you guys don't have any questions, right now, remember that you can ask me anytime on Google Hangouts or over email or whatever. Also, please join the study session to cure me of my boredom and also get your homework done. Two great things at once. And yeah, thanks for coming again and have a good rest of your day. Hopefully, I'll see you on a study session. Bye, guys.